Good morning, ladies and gentlemen. I've just realised I'm here to represent industry. Excellent. As an introduction was quite accurate, I don't need to rehash who I am and what I am. But when Chris contacted me a few weeks ago and said, I want you to come and talk about redistributed manufacturing, I have to be honest, that's the first time I'd ever heard the term. So how does a man in my position approach a presentation about something he knows nothing about, which is pretty normal for me, actually. So here goes. So what I thought I'd do this morning is tell you a little bit about who we are. Not a sales pitch, because I am not a salesman, but there is a fine line between information and selling, and I hope I've trodden on the right side of that line. Bit of what we do. And the key thing is our approach to manufacturing, because what I can bring to this network is a lot of experience and a lot of practical knowledge about manufacturing. I've set up lots of manufacturing systems in lots of different places of different scales to do different things, and we'll take it from there. And also give you an up-to-date understanding of where my areas of expertise and interest are, and at the end, just my initial thoughts on redistributed manufacturing, pretty much from ground zero, because I've done a bit of reading over the last couple of weeks. Okay, so Renishaw is a world-leading metrology company. Our world headquarters is about 20 miles north of Bristol, on the edge of the Cotswolds, hence the under edge in the title of where we are, Wootton under edge. And we operate in lots of different markets, but part of what we do, basically a lot of it is to sell customers technology which allows them to transform their manufacturing efficiencies. We do an awful lot to sell into research institutes kit to help them find out things about other stuff. And over the last 10 years, we've grown into a medical devices and medical intervention company as well. So we are a truly global company. At the end of last year, we turned over 355, and our financial year ends in June, and I think we're going to be somewhere close to $500 million this year. We spend an awful lot of on R&D, which makes us atypical, and we spend an awful lot more on R&D than most companies because we're very much an IP-driven organisation. Inventing things that no one else has done and finding novel solutions to customers' problems is why we have been so successful. We have a team of patent lawyers to back that up. We broke 4,000 this last month in terms of employees across the world, and we are represented in 32 companies. But for a truly global company, we have a very local perspective on manufacturing. Most of our manufacturing is within 30 miles of where we're stood. We've got a machine shop in Stonehouse just outside Stroud. We have our main assembly shop in Woodchester just outside Stroud. We have an assembly plant in Dublin, and the reason it's in Dublin so far away is because our chairman is Irish and his brother. In the very early days of Renishaw, managed our assembly plant in Dublin, and we've kept it mainly because the Irish have over the years, even though we are in a great European Union, they have a different tax regime to everyone else in the UK, and it makes good sense financially to sell stuff out of Ireland because corporation tax is lower, so we've kept it. And you may think that Pune doesn't fit into that very well because Pune is about 3 hours outside of Bangalore, but we have a whole family of products which sell in large numbers in the Far East, and they're quite heavy and not that expensive, so we decided to make them locally to where they're being sold. So we've got an assembly plant in Pune, and they've got a local network of suppliers which feed that plant. It saves us shipping thousands of tons of products, thousands of miles across to India to be sold on from there. So that, in effect, is a local solution. So our expertise, I won't spend too long on these because I'm quite conscious that I haven't got long. A lot of these slides I often expand into 2-hour lectures or even whole day seminars, so you'll have to forgive me if I don't go into much detail. So this is the stuff that we sell to, basically to manufacturers to improve the efficiency accuracy and repeatability of their manufacturing processes. We sell an awful lot of industrial metrology equipment, and on that slide, because there was nowhere else to put it, I've added additive manufacturing. Very recently, Renishaw has acquired the ability to make and sell 3D metal printing machines, and that technology is going to be the future of manufacturing. Well, if we get our way, it will anyway. So there's a lot to be said about that. And we do a lot in the healthcare regime. We make teeth. We do an awful lot with neuroscience. We do things like deep brain stimulation, drug delivery, and all the planning software that goes with telling neurosurgeons where to drill holes in people's heads, which is quite a science. Okay, I won't go to some products. They're very, if you want to encapsulate what we make in a few words, they're very high value stuff that we sell to people, and not much more we can say about that, really. There's a lot of very high-tech stuff in there. But just to get on to the meat of what we're here today to discuss, our approach to manufacturing has always been very similar to what we approach, the way we approach the design of our products. We like to patent our manufacturing technology as well, because how we make things is as important to us as what we make. And by doing that, we have an edge over lots of our competition. We have a very strong belief in design for manufacture, and that ethos goes right the way through the business. Low work in progress, I mean, Chris hinted at this earlier, low work in progress is a very key part of what we do. Inventory, if you go on, I've been in so many factories where you have piles and piles of half-made components that are sat in front of a machine waiting for the next operation on the process layout. We don't do that. It goes from raw material to finished part in one operation if we can. Not possible in every instance, but if you walk round our shop floor, you will not see great piles of half-finished stuff. And also, we use very high levels of automation, which is another part of what Chris talks about. If you measure on manufacturing shop floors the number of machines and the number of people that operate those machines, in a very traditional sense, one-to-one. So one man, one machine is a very traditional and a way of approaching manufacturing. And there are still, most factories that you go into will have a ratio somewhere in the region of 1-to-1. Ours is 4.5. So we've got 4.5 machines per person on the shop floor. And that's only possible by high levels of automation. And this one here, this is in itself a one-day seminar. This whole sentence, quality designed in rather than in rejects inspected out. That's an ethos that is extremely important. And we buck the trend. Chris talked about outsourcing and globalization. We strive very hard to make everything we can in-house because it gives us control over the quality, and it's the way we've always done things. Now, I understand that not many people in the room are manufacturing engineers, so I'm not going to stress too much about these kits. This is a picture of our machine shop in Stonehouse. It's very clean and it's full of very high-tech equipment. This is a system I developed a few years ago called Rantic, Renishaw's Automated Milling, Turning and Inspection Centre. And I guess nobody can understand what it does now. Anyway, that's the mainstay of our machine shop, and we've got about 5,000 different part numbers that we make on that system. We've got small, complex turning machines. When I say complex, if you looked at that without its clothes on, it would have about 9 or 10 different axes that all work independently. So that is why I mean by complex. and we've got those which are small ones, and we've got these which are big ones. So basically 3 classes of machines: small turning, large turning, and milling. And we make almost everything in the Residential Empire that way. And last but not least, the technology that Chris alluded to in his speech, 3D metal printing. We not only make and sell these, we use them in our own production. What you've got there is a picture of some dental products. They're crowns and bridges that we sell to dental laboratories, and also we're beginning to build up a repertoire of stuff in the maxillofacial arena, and we're working very closely with quite a lot of medical devices companies. And I think one of the big future markets for 3D metal printing, particularly in titanium, is going to be for bespoke implants for patients. So what can Renishaw bring to a network that's looking at redistributed manufacturing? We're a local company. We manufacture high-value products for a global market. So in that respect, we can bring insight into the pressures and drivers on businesses like ours that can result in globalization rather than localization. So why do businesses choose to do things on a global scale rather than a local scale? And what can we do to reverse that trend? It all comes down to money at the end of the day. And we use state-of-the-art manufacturing techniques and processes, so we can bring insight into how these can transform the economics of manufacturing. And we manufacture and sell metal 3D printing machines. I can bring insight into how this technology will transform how things are made. And what about me personally? I'm very interested and very active in exploring the economics of manufacturing. In particular, this thing called hybrid manufacturing. If that means nothing to you, I apologize, but what it means is a combination of additive processes and subtractive processes like CNC machining, and also what they call transformative processes like polishing, cleaning, and things like that. Most components are neither additive or subtractive. Most of them have combinations of these, and people who sell additive machines seem to forget that there's an awful lot of stuff other than the additive that needs to be done. So I'm trying to develop systems which are truly hybrid, that you go from raw material to finished part within one system. And this design for manufacture, what people talk about in DFM, in manufacturing circles, is usually design for machining. So if you add design for machining and design for additive, you get what I'm striving for is design for hybrid. So a full design package. So if you've got a part, there's some algorithm and some underlying logic that tells the designer whether it's best to make that part additively or subtractively, and which features are best made, and how much stock do you allow, and all that stuff. Also very interested in the design and development of automated manufacturing systems, process control, and all that stuff there. I don't need to talk through that. Okay. Just very quickly, some initial thoughts on redistributed manufacturing. This paragraph is Chris's. This comes out of the bump he sent me. So I picked this paragraph. It's a very good encapsulation of redistributed manufacturing. Highly adaptable manufacturing processes capable of operating at small scales offer the possibility of a new understanding of where design, manufacturing and services should be carried out to achieve the most appropriate mix of capability and employment possibilities in our economies, while minimizing environmental costs and stuff. Right, some comments. Take the first line. Highly adaptable manufacturing processes capable of operating at small scales already exist. Modern CNC machine tools and 3D printing, both in metal and polymers and ceramics and anything else, already exist to make this true. So there is already the technology available, in my opinion, that would facilitate this redistribution of manufacturing. This is the key one. The possibility of a new understanding and employment possibilities are the phrases I've picked out. And this will need a major shift in education to ensure that the next generation has enough engineers in it who are capable of the understanding and the application of this technology. My experience today is that when I talk to graduates who've got really good degrees from universities, they don't know how to make anything. Yeah, it's quite straightforward. You're not going to get to redistributed manufacturing unless there's enough clever people who know how to use it. Yeah, there we are. And lastly, minimize environmental costs. Now, redistributed manufacturing will put a lot of machine tools and a lot of high-tech stuff into small companies. Each one of those represents a huge investment in energy. It takes a huge amount of energy. If you looked at the carbon footprint and the amount of energy, the amount of cast iron, the amount of stuff that goes into making a machine tool, it's enormous. Then if you add to that all the energy and all the stuff that you need to feed it over its working life, it's an enormous drain on the environment. And we're looking at putting all these in many factories. We need a shift towards a new machine structure and a new type of machine. And I'll just leave you. If no one knows what PKM stands for, it's parallel kinematic machine. And there's one. This is a parallel kinematic machine. Does all the things a machine tool can do, it just doesn't have 9/10 of the weight in it, and is potentially the way forward. And I'll leave you with that thought. Okay, thank you very much for listening, but if there's any questions, I'm more than happy to take them.